This is a lensometer. In this introduction video, we will identify its parts, learn how to calibrate it to 0 point, and learn how to identify the sphere lines. Let's go over the different parts. This is the power switch. To help the light bulb last longer, keep the power off when the lensometer is not in use. This is the locking lever. It's used to raise or lower the position of the lensometer for the user's individual height. This is the lens table. It is where the bottom of the lens or glasses sits. It is used to ensure the glasses are sitting level. This is the table lever. It is used to adjust the sitting height of the lenses being verified. This is the lens stop. It is where the back of the lens rests. This is the spring clip. It is used to hold the lens in place. This is the lens center marker. It is used to apply a temporary ink mark to identify the center of the lens. This is the axis dial. It is used to determine the axis powers of a lens. This is the power drum. It is used to determine the lens powers. If you don't see the power readings on the drum, look through the eyepiece to see if the readings are viewed from there. This is the eyepiece. It's used to view the readings and calibrate the lensometer to 0 point. Before using the lensometer, you want to ensure that it's adjusted to your 0 point. Make sure your lensometer is off, then lower the table, pull back on the spring clip, and place a white sheet of paper on the lens table. Pull and release the spring clip to hold the paper in place. Without looking into the eyepiece, start by turning the eyepiece counterclockwise until it stops moving. If you look into the eyepiece, you will probably see that the reticle is out of focus. While looking into the eyepiece, turn it clockwise. You can stop turning once you see that the reticle is in focus. Pull back on the spring clip and remove the white paper. Your lensometer is now ready to use. If you're using a lensometer you're not familiar with, you will need to be able to identify the sphere lines in the illuminated target. Start by turning on your lensometer and looking into the eyepiece. You will probably see a yellow light. Turn the power drum until you will notice that the yellow light becomes more and more focused, finally resulting in crisp lines. This is what an illuminated target looks like. As you can see, it is made up of a set of intersecting sphere and cylinder lines made by light. Let's learn how to identify which set of lines are the sphere lines. To do this, you need a pair of glasses with a cylinder prescription that you already know, and the prescription should be read in minus form. For example, here we have a pair of glasses with a prescription of -1, -2 at an axis of 170. Start by setting the axis wheel to 170 to match the axis in the prescription. Now set the power wheel to -1 to match the sphere power. Next, pull back on the spring clip to move it out of the way and place the glasses in the lensometer. While holding the glasses flat on the table, look through the eyepiece and center the lens by moving the glasses up and down with the table lever. When you do this, you can see that the illuminated target also moves up and down with your motions. While holding the glasses flat on the table, you can also slide the glasses right and left. When you do this, you can see the illuminated target also move from right to left. Use these motions until the illuminated target is centered on the crosshairs. When the lens is centered, pull back on the spring clip to hold the lens in place. The illuminated target is made up of a set of sphere lines and cylinder lines that intersect each other. To identify the sphere lines, simply observe which set of lines are in focus. Those will be the sphere lines. In this case, you can see the 3 thin lines close together are in focus, so those are your sphere lines on this lensometer. Pull back on the spring clip, remove the glasses, and remember to turn off your lensometer.